Our next speaker is Aleksandr Barmin. Good day, Aleksandr.
Good day, Seva. Nice to see you. Nice to hear you. How are you doing? What's the best in your location today? Where are you from, by the way?
I am currently in Poland, and our speakers are from anywhere, if I'm anywhere. As I see on the Aleksandr's LinkedIn page, he is describing himself as he have a passion for Java-based frameworks. Also, he has a PhD. Also, he have a YouTube channel, and on this YouTube channel, I saw this kind of Google designed interviews when you are solving the programming problems.
Yes, that's true. That's true. I do my best in order to increase my public presence, and that's true. I have already conducted 15 episodes of the Weekly Link show, and right now I'm driving a new lead code with me show when I solve coding challenges, like from lead code. And in case you want to support me, you always can subscribe to my channel. I will be really happy to see new subscribers there.
Thank you, Aleksandr, for sharing, and thank you for your videos. Talking to today's topic, as you have a PhD, do we expect a very serious talk today?
No. So obviously not. I have already seen a couple of previous talks, and all of them are really technical, and all they're fun as well. And what I want to talk about in my talk today, I think you will know more about it during the talk itself. It's not a technical talk. It's just my previous experience in building different kinds of software and issues I faced doing that. So it's not a rocket science or maybe brain surgery. You will definitely enjoy this talk. And of course, it is about developers' effectivity, developers' efficiency, and about predictability, obviously. So nothing about PhD. You're right.
Thank you, Chief Software Engineer. The stage is yours, and I am excited.
Good. Thank you very much, Seva, for setting this stage for me. Let me start. And as ordinary, I'd like to start by introducing myself. As I already was introduced, I'm a chief software engineer. I've been to software engineering for more than 12 years. So honestly, I don't really remember when I started, but I remember I wrote first line of code in 1995, many years ago. I have experience in different business domains like enterprise content management, education, legal, banking, and so on. Obviously, I have failed projects. I failed a lot, and I want to share some stories with you today. And apart from having a PhD and YouTube channel, which is more important, I am a head of UK engineering community. If you want to join a new immersive community, follow this link and you will join us. Well, and today we're gonna talk about things you as developers deal with every day. Complexity. But before we start, I have a question to ask. How to make the delivery predictable? Even if you're a manager, you know what to do, right? You know already. You need to hire and engage brightest engineer you can find on the market, right? The highest 5% of engineers. You need to establish clear and stable requirements. You never change it. You set it in stone, it's there. You have to have well-defined architecture. You can involve big head architects in order to do that. You need to follow best engineering practices, solid, clean architecture, well-designed framework, keys, dry, and so on. All of them, you should follow all of them, otherwise it will not work. You need to build microservices because it's a modern approach of delivering software nowadays. You have many independent beasts and pieces, and all of them can be deployed independently, scaled independently. It's a modern way of delivering predictable, right? You also should use clouds because, if you have your own data center, it is not so fascinating as it should be. Because if you on Amazon, you can say, our clients are widespread across the globe. This is fantastic marketing. Also, you should definitely use all the modern tools we have And obviously, you should use AI. ChatGPT, Copilotix, Code Whispers, anything you can find, you should use. You need to establish CI/CD because without streamlining the delivery process, you can't deliver your software in a predictable way. And you have to be agile. In order to be agile, you have to follow all the daily ceremonies. Without ceremonies, agile does not work. So I suppose it's a good time to wrap up my talk because I have already told you all the secrets how to make delivery predictable. But the question is, does it all work? And it's a very, very good question because I was working on many projects and complexity is the single thing we need to deal with. Let's start with a simple example. I'm in London right now, but previously I lived in a different country. And as an immigrant, the first thing I need to do is to open a bank account. You know how to do it, yeah? You take all the documents you have, you go to the bank branch, you show all your documents and everything you have, and after magically in a few days, you will be happy owner of a new current account and a debit card. It's simple as a finger click. When I started a new digital, fully automated onboarding journey for one of our customers, I finally realized how complex it is. We have data capture. We need to make sure that our applicant entered all the necessary data in the proper way. Apart from that, we need to be sure that people who try to apply is who they are in the reality. We need to do identity verification. And in case if you're in the bank branch, the person who sits in front of you can do it by his own eyes. It's easy. But when you're, for example, doing it in an automated way, it's hard. You need to prove that document your applicant shown to you is a real original. You need to do document verification. And finally, you can create a customer and open account. It sounds easy, but actually inside the bank, there are many software systems and all of them should be updated in the consistent way. And finally, you need to issue your bank card. It is easy, well, yes and no, because apart from that, we also have bank regulations. We also have local rules. We have some rules of processing the data, personal data, and many others. And actually, all these things are called inherited complexity. It seems complicated because it is really complicated. Our world is complicated. And on top of it, we put another layer, a software. And the software brings accidental complexity. We can't do anything with the existing inherited complexity because the world is hard, but we can deal with the complexity with the software we create. Modern software development is not the same as it was 15 or 20 years ago. I heard the story if you build a snake game for this ancient Motorola device and you need to release the same game for the different platform, for Nokia, for example, you have to build it from scratch. It's a completely new software. You never asked to release a Snake 2.0 game with advertisement bonuses and paid subscriptions. In order to get a new version of the Snake game, our customers has to go and buy a new cell phone. Nowadays, the world is different, and the software have to adapt to changing business requirements. It should easily accommodate new business requirements, new business features. We have to be agile. And software engineers also have to deal with it. We predict changes. We do our best to predict changes. We add extension points like interfaces with multiple implementations. We add feature toggles. We version our API. We split our users. We add layers of abstractions. We externalize configuration and even add user-friendly admin interfaces in order business people to be able to configure our software on their own. But in common, what we do, we make our software even more complicated and increase accidental complexity. Yeah, so we actually create a complexity for our own, for developers, because we have to support and maintain this software. complexity make it hard to adopt a new change, you can just go and add a new REST endpoint to the big enterprise software, because you have to build a specification first. This specification has to comply with local rules, with data dictionaries, data vocabularies. You have to follow local best practices. You need to make sure that no of existing contracts is broken. Well, it's hard. It's not easy, it is hard. And in order to tackle this complexity, we as engineers already come up with a great option. We decided to introduce microservices. Unfortunately, I can't see your reaction right now, but in case if you put pluses into the chat, I will see that actually you use microservices and you've been into the situation like I explained. So I encourage you to put pluses into the chat. And to tackle all these things, you can say, well, you are not in the ancient era, you're ancient dinosaur, because nowadays to solve all these problems, we follow modern design practices. We create microservices. They are small, tiny, you can just go ahead and replace one box with another. You can have any spaghetti code inside, it doesn't matter until it works. Yes or no? Well, no, because you have to think about deployment, you have to think about semantic versioning, you have to do canary releases in order not to affect your users. You have to think about reliable sync and async communications. Now you have clouds with cryptic payment strategies, and it is not an overwhelming list because it grows as more technologies you bring. But what's happening in reality is that we bring more complexity to what is already complicated. But actually, we shouldn't. We are victims of our own smartness. If we take a look into the failed project, it's really easy to start finger pointing. But I want to point to myself and ask what I have done to make things even more complicated. Actually, we as developers, we made software harder than it should be. We can identify 5, 10, 20 things, but let's focus on the most interesting. The first example is from my life. Years ago, I was working on a project for one of the world's biggest airlines. We needed to replace an existing ECM solution with a brand new software. And this software should be flexible enough in order to accommodate many changes in business requirements and in order parts of it to be used in different projects in future. Isn't it a bright, shiny new goal? What can go wrong, obviously? Well, we knew that components will be reused, so that we come up to the design wisely, and we designed it with reusability and extensibility, and obviously configurability and many other abilities in mind. Isn't it awesome? Yes, when you sit in a meeting, it is not fascinating with other developers. It is not fascinating to say, I am building a form of incoming document. I'm building a review assign process. I'm building the boring business application, and it will be done by the end of the day. The next day, the application will start bring revenue to the customer. No, it's boring, because the person who sits next to you says he builds a framework. He builds an abstract factory, and bidirectional root path resolver, Impel, and other clever things from Gango for book and other clever books. Yes, this guy is smart. He is really cool and extremely clever. If you ask him why it is necessary to have an abstract factory, there definitely will be a holistic answer saying that it will help in future projects. It will help dozens, if not hundreds of engineers to build their software quicker. But will it help the business? Come on, you don't have to be boring. You need to start thinking out of the box. Okay, by the end of the day, all these factories, configurers, and adapters are written, and you may start writing the actual business logic. But you remember, the software should be configurable. So there should be a way to change the behavior. Well, how we can make it worse? By using XML or JSON? No, we did it worse. It's a Stone Age. Everybody can read our JSON and steal our business data. We use JavaScript and Groovy for configuring. We had code written in Java using Java EE, that's true, and it was run on IBM WebSphere application server and took 15 minutes to deploy the change, and developers start struggling with it. So we come up with an idea, why shouldn't we give them an interface then they can put their changes a piece of code into the form and changes applied immediately. It was a great idea. Development experience were improved drastically. But when we started delivering the application to customer, we understood that the configuration is inconsistent. No one except developers can write these groovy scripts to set color of a button. Performance is slow because of too many moving parts and layers of abstraction. Application just does not work of some configuration conflicts. At the end of the day, yes, we built a framework for building ECM solutions. It was configurable enough to accommodate any changes, but the project was failed. We failed the project. So what I learned that unnecessary flexibility makes your software worse. It is easy if it is easy to hard. If it's hard to test the application, it's hard to develop it. If it's hard to develop it and test it, it's really hard to prove that it works properly, and it's hard to predict behavior after changes. We have to move forward. Have you ever been in the situation when you look at your code and can't understand how it works? It's been a few times and I'm not really happy with it. Again, another example from my ECM past and previous experience. I'm talking about it now because the software were rewritten, now it works as expected and don't have these strange side effects. But at the moment of debugging, I spent days trying to catch these bugs. When modern document-oriented database like MongoDB were not yet available, there was another major player on the market. It was IBM Domino. I really like it because it allowed to write software really, really quick. Rich development environment, flexible document model, simple programming language on top of Visual Basic. Everyone knows basics. Basic, right? Right. So I will show a piece of code. As ordinary code is split into libraries. On the left-hand side, you can see the library, which is super simple. It has a function, it has a variable on top. The variable is defined as dim doc as .document. Well, name doc is really suspicious here because we're in the document management domain, and doc is widely used in this application. And this is a global variable. And in most scenarios, application works gracefully until one single piece. We have a dialog which opens a document, and this document, when it's open, it uses library B, and library B imports library A and does some changes in it. Don't you see any suspicious line in the library B? Well, if you see it, please put it into the chat, but let me proceed, because when you have a big code base, it's really hard to find a place when this global variable mutates. Because the main problem is, this is a really unexpected change, because in case if software is designed properly, you never have it, but right now you faced it. And this is the most cryptic thing. It is called unexpected mutability. Have you ever been in a situation when you look at the code and can't understand how it works? I've been a couple of times and I'm not really happy with it, because there are two kinds of code I really don't like. Code that does not work, but I can sort out it and ask the question, what is wrong with it? I can fix it. And on the other hand, there is a code which works but shouldn't, and it is really hard to deal with it. The problem I described earlier happens because of uncontrolled mutability. The code should be as transparent as possible in order the other developers not to struggle so much to understand what is not good with the code. We write software to be executed on computers, but to be maintained by humans. If it is really hard to read the code, it is hard to maintain it. It should be as simple, and if not, it should be extremely well documented. Time to deliver a change can be directly converted into money. More complicated change costs us more money. It doesn't matter if change is stupid. It works, that's fine. Moving forward. What every programmer does every day? You can say that you solve business problems, add new features to the application, you write new code, but actually what you do is you stare at your code for hours, trying to understand what it does. When you're in the stream of work, any interruption can make you angry. You have just spent an enormous amount of time and energy trying to build a mental model of code, and you're in the middle of complicated computation somewhere in your head, and you're interrupted. Hope now you understand what software feels when it is interrupted by process manager. After saying of a few bad words, you're starting to load this mental model back into your head, and all these interruptions are completely brain damaging. But why are we building so sophisticated mental models? Just because software components are interconnected, and as more relationships every component has, it is more complicated to reason regarding its behavior. Some time ago, I was working on a very complicated software for publishing legislation of the European Union to the data mart. In a nutshell, it is nothing but XML processing. We all know that how to do it. Part of the system was written from scratch in Java. It was a data reader. Another part was written in Perl. It was an HTML converter because the system initially was developed many years ago, even before XML was invented. Next bit was written in different programming language. It was document converter. Another one is table of content creator, and even a piece of the software were written in Lua just because this piece of code was executed in the Redis cluster. So it looks like software you write every day, right? Because we have many pieces of code, all of them were orchestrated by a collection of bash scripts. So nothing can make it worse. If it is not bad enough, you can add bash scripting to make it even worse. And when you load all these components into your head, it can blow up already. But for me, it was necessary to extend this software and add support of another type of document. When we opened the code base, what we realized is that it is not only hard because it's big, it is also not well structured. Loading methods, many nested ifs, no comments, no meaningful names of variable. And in order to add new document type, it was necessary to extend and write a few more lines in every single application. It was painful, but we did it. But why was it painful? It was painful because we had tightly coupled components, and it is really hard to maintain tightly coupled code, and it is even harder to extend it. It's all about frequency of changes. If the code does multiple things, like in my case, it supports multiple document types, it has many reasons to change. It has low cohesion. And in order to introduce any tiny change, we need to keep all this code base in mind. It's mind-blowing. So in order to make, again, your development and delivery predictable, you need to write simple code, which is really easy to maintain. If you're long enough into software engineering, you know that you don't need to reinvent the wheel every time. You can just add a dependency. But how many dependencies do you really have and manage in your projects? So if you're still with me here, please write it down into the comments. I want to see how many dependencies are in your projects. And I want to explain and want to show to you my project. Okay. In a nutshell, it has REST API, it has a few message listener, all good. It's a normal project in enterprise. All these interfaces are on top of the service layer, which is fine as well. We have data access layer, and all these components are written in Spring Framework, and I really like it. I know that conference is about JavaScript, but I really believe that you have exactly the same problem in JavaScript world as well. And Spring Frame and we use Spring Framework just because organization uses it everywhere. And Spring Framework has its own dependencies. It is hundreds of dependencies. And I'm really proud and I'm really happy that Spring Framework manages all these dependencies on its own, because it is mind-blowing because we have many dependencies. If you need to deal with database, you need to bring a dependency like a hibernate, and this hibernate will not work with a particular version of bytebody or cglib. There should be a very strict, there is a very strict dependency between dependency versions, and I'm really happy that Spring Framework deals with it, because it's extremely hard to find a fragile balance to make everything working. Well, but the problem is, because we have many dependencies and I am still suffering from it. Every time any dependency has a vulnerability, the build pipeline blocks, they work fully. Just because someone can steal all your customer data via vulnerability in the YAML library that reads one single configuration file, then application start. This is a major vulnerability. I would admit it's major vulnerability. You cannot proceed anyway. You have to carefully update all these libraries, all these dependencies, and other libraries that relies on it. So you have to take all your mind capacity, find all the interconnections with dependencies, and update them one by one. Well, but still, it is not happening as regularly as it should be, but still it happens. If you work in a big project in a big company, most of the reusable components should have already been written for you. If you need login monitoring, there is a library. If you need audit, it is here already. You need retrieve backoff, just take a library, DTO, problem solver lib, and any other magic lib you want to have, you have it. And until I started using dependencies which are maintained by other teams, I never fully believed that jar hell exists. Every library I use has its own collection of tweaks. Every library has its own version of dependencies, and not all of them work together. Just because my fantastic code is on top of it, I still have a big bunch of dependencies. You know, Java 11 is going out of support in 2 weeks, and I have to update my project to use Java 17. My code, which is on top of it, it can be executed with any Java version. I don't really need to even think about it. But it has many dependencies, and all these dependencies cannot run on Java 17 because I need to carefully update them, maybe not one by one, but at least replace the Spring Framework. And another important thing to mention while talking about dependency is technology addiction or CV-driven development. How many of new fantastic features which were introduced in Java 21? By the way, it was released yesterday. Vector API, string templates, unnamed patterns, and many other cool features. Other than that, we have Spring Boot 3, which also was released, and I can start using it. Many features. But why haven't I adopted it yet? Don't get me wrong, I really like new things. I even have YouTube show when I'm talking about Java and new things, but I don't want to do it just because I shouldn't be the one single person who knows it. Don't follow resume-driven development. You can't just go and introduce a library just because it looks good in your resume. Imagine you hire a person with a big list of libraries in your list. I know, its time is up, just a few slides left. Next slide will be the final one, no worries. And what's the problem? The question you need to ask is, when he joins or she joins the team, will he bring all these libraries to the project? And I see its time is up and I have to wrap up, and this is my last slide, by the way. I showed a few examples of accidental complexity from my previous experience, and I believe you may show even more examples from your personal experience. First of all, I want to say is that inherited complexity comes with business domain and you can't remove it. Accidental complexity is something you introduce on your own. Do your best to remove it. And actually, as for me, the main skill for the software engineer to see difference between accidental and inherited complexity. Yes, you may foresee some great places for extensibility. You make components configurable, extensible, replaceable, and so on. Unfortunately, you can learn how to do it by reading books or watching YouTube. You have to learn it on your own mistakes. And this is how engineering maturity grows. We talked about different things, sources of which accidental complexity is coming from. I sure you say me, I am sure you can add even more to this list, but it's my story. And actually, this is the main answer to the main question I asked at the very beginning of the talk. What can we do to embrace predictability in software engineering? Beat accidental complexity. Run away from it. We shouldn't learn how to deal with we should learn how to deal with complexity. We have to have the wisdom to minimize it. Maintainable code is a gift we're giving us to the future. Hope that was useful. Thank you very much for coming. Thank you very much.
Thank you, Aleksandr. It was very useful, and I think that it was quick in the end, but I still hope that it was effective for our audience. And maybe there are guys send a couple of questions. If you have an access, maybe you can answer in any form you are comfortable.
I don't think I have, yeah, unfortunately, oh yeah, I see. I finally managed to find a proper tab in the interface to answer the question. I see question from Sonic Volk, and I see he put plus when I asked. Thank you very much. It's my royal like to you. Also, there is a question. Let me choose one and answer it. Also, what if an experienced developer is heading the team and making bad decision? How can we change that better? From my experience, the complicated and significant decision should not be made by one single person. That's true. This is why we have audit, and this is why we have, let's say, engineering community. If you think that this is a big decision which may affect many teams, which should be addressed properly, you can bring a proposal to some group of other engineers for review, and they can say, okay, this decision is good, nevertheless, these bits should be improved. It is really hard for selfish people. I admit it is hard for selfish people to follow this. But you know, our software should not suffer from decisions of one single person. So what I would recommend you to do in this scenario is to ask this engineer to present his decision at least to the group and address all the concerns. It's painful, you have to answer very inconvenient questions, you need to address many things, but still at the end, it will make your solution better. You know, roughly speaking, 10 years ago, I was thinking, when I did this exercise, I was asking myself, why do they ask questions? Don't they see my shiny, bright idea? And year after year, I realized that mind map in my head and mind map in the head of my colleagues is not the same. We need to fill this communication gap. This is why we have diagrams, this is why we have communities, we have forums, we present our solutions. This helps us to equal our understanding, and maybe it is definitely worth doing that because people help us. Thank you very much for having me today. I wish you a fantastic conference and a good day. Well done.